Okay, this problem, I'm not getting the same numbers that he's getting, but I don't quite understand his numbers, so I'm going to go through and solve it the way I think it should be solved. It says that there are 3 charges on the corners of an equilateral triangle, and it asks you to find the electric field at a point midway between the 2 charges on the x-axis. So that, to me, means that we're finding the electric field at this point here, right in between the 2 charges on the x-axis. That would be our P. Okay, so if I think about my triangle, this is point P. At point P, my field due to the first charge, call this one Q1 again, Q2, and this is Q3. My field due to Q1 is going to point away from Q1, so I'm going to have, at P, I'm going to have a field like that. And then for Q2, this is a negative charge, so it's going to be pointing towards the charge. So again, I'm going to have a field that looks like that. So I'm going to want to add these two together in the same direction. And now what about the field due to Q2? Well, that's going to be pointing away from this charge Q2, so it's going to want to be pointing this way. So for Q1 and Q3, I'm going to have fields pointing to the right, and for Q2, I'm going to have a field pointing down. Okay, so E at P is equal to E from 1 plus E from 2 plus E from 3, the superposition principle. Okay, so I'm going to plug in, and I get K Q1 over R P1 squared. The difference, or the distance between RP and R1. All right, plus K Q2 over R P2 squared plus K Q3 over, you know what, let's forget that for a little bit because we can't really do that now. So let's just forget, I'm going to erase all this. The reason I can't do it is because they don't all lie on the x-axis. So let's erase, oops. It's a word. I'm going to erase this. Maybe I can select objects and erase it a little bit easier. Okay, so I still have my drawing here. Okay, so what I'm going to do now is instead I'm going to calculate E, let's say E at P for X, so the X component. So for the X component, I have E1 plus E2. Those are both going to be in the positive X direction. So I can add those together. So K Q1 over R and the distance between P and 1 squared plus K Q, actually this is not 2, it's 3, isn't it? This is 3. Okay, K Q3 over R P3 squared. Alright, I'm going to pull the K out, and so I just have Q1 over R P1 squared plus Q2 over R P2 squared. Not sure why I'm losing the top of my P, but whatever. So close parentheses, so my EPX equals 9 times 10 to the 9th Newton meter squared per Coulomb squared. And then my Q's, this one is 2 times 10 to the minus 6 coulombs over, and the distance is 0.25 meters squared, plus 4 times 10 to the minus 6 coulombs over 0.25 meters squared. Notice I didn't put in the signs, and that's because I dealt with the signs when I dealt with what direction they're going to be going in, and the fact that the electric field is going to be positive in the positive x direction. Okay, so when I solve for EPX, I get, when I plug in those numbers and multiply out, I get 8.64 times 10 to the 5th newtons per Coulomb. And now when I want to calculate EPY, I'm just going to use E2. And that's because E1 and E3 only point in the x direction at point P, but for E2, it points in the negative y direction. So here I'm going to have KQ3 over RP3 squared. And that's equal to, P there, that's equal to 9 times 10 to the 9th Newton meter squared per Coulomb squared times 7 times 10 to the minus 6 coulombs over, it's all over. And now I need to figure out what that length, that distance is. And so I can use trigonometry here. So if I know this is a 60-degree angle here, let's try over here. This is a 60-degree angle, and this is my distance right here. This is my distance from the charge to that point P. So if I look, this is 60 degrees, and so this is opposite. So I know that sine of 60 is equal to opposite over hypotenuse. So that's going to be, we'll call this y, over 0.5. And now I just need to multiply by 0.5 on both sides. Cross these out, and I get y is equal to 0.5 meters times sine of 60. 6. So y is equal to, we find when you multiply out 0.433 meters. So I can plug that in. 0.433 meters squared. And I find that EPY equals 3.36 times 10 to the 5th newtons per coulomb. Okay, so now I have my EPX and my EPY, so I can find my E total by taking the square root of EPX squared plus EPY squared. And so when I do that, I find that the magnitude is 9.27 times 10 to the 5th newtons per coulomb. And to find the angle, so theta is equal to tan inverse of EPY over EPX. And so I find that theta then is equal to 21 degrees, and that's measured, so if this is my triangle, and this is where P is located, that's P, then I have an X that looks like that, and a Y that looks like it's less. So I have something that looks like that. So I'm going to assume I'm closer to the x-axis. So the angle is going to be this angle from here. So it's below the x-axis by 21 degrees.